Road to Olympiad.
Welcome to RTO. Consider the following problem. Find all the real number m such that the equations x squared minus 2mx minus 4m squared plus 1 times x squared minus 4x minus 2m m squared plus 1 is equal to 0 have exactly 3 different roots. This problem may look easy, where we just need to solve for the two quadratic equations, considering one of them have 1 root and the other one have 2 roots. However, there's some important detail to take notes when we are solving the equation that way. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by letting the quadratic equation on the left be equation 1 and the quadratic equation on the right be equation 2. Like what we mentioned just now, we can consider two cases. First, where equation 1 have 1 root and equation 2 has 2 roots, and second, the equation 1 have 2 roots and equation 2 have 1 root. For case 1, consider the discriminant of equation 1. Notice that this discriminant can be simplified into 4m squared plus 16m squared plus 1. Notice that m squared is a perfect square, and thus the sum is greater than 0. So this is not possible for equation 1 to have only 1 root. So case 1 is not possible. As for case 2, equation 1 indeed have 2 roots. So let's consider the discriminant of the second equations, which can be simplified into 16 plus 8m times m squared plus 1. We can simplify this one as 8m cubed plus 8m plus 16, or 8 times m plus 1 times m squared minus m plus 2. To make the equation have 1 root, we need this discriminant to be equal to 0. However, notice that m squared minus m plus 2 can be written as m minus half the whole thing square minus 1 over 4 plus 2, which is equal to m minus 1 the whole thing square plus 7 over 4. This is a sum of a perfect square and a positive number, and thus this must be greater than 0. So, in order to make the discriminant of equation 2 be equal to 0, the only way is by having m is equal to negative 1. A lot of people will stop here because we have considered all the cases and we have found the value of m that we need. However, if we substitute the value of m into the two equations, we'll get the first equation give us x squared plus 2x minus 8 is equal to 0, which can be factorized as follow, and we get the roots x be equal to 2 or x is equal to negative 4. And equation 2 will give us x squared minus 4x plus 4 equal to 0. This one can be factorized as x minus 2 the whole thing square is equal to 0 and give us the roots x is equal to 2. Notice that in this case, we only have two solutions, x is equal to 2 or x is equal to negative 4, which is not what we want in the questions. Therefore, this case doesn't give us 3 different roots as we desire. So is it means that there's no real number m that satisfies the equations? Not really. There's another case to consider. Case 3. Both the equations have 2 roots, but there is one common root of the two equations. For this case, we assume that k is the common roots. Then we can substitute k into both the equations and we get equation 3 and equation 4. Taking equation 3 minus equation 4, we come up with these equations, which can be simplified as this one. Solving the equation again gives us two solutions, m is equal to 2 or k is equal to m squared plus 1. If m is equal to 2, both equations will give us x squared minus 4x minus 20 is equal to 0. This will only give us two solutions, so m is equal to 2 is not the real number we are looking for. If instead k is equal to m squared plus 1, then equation 3 gives us this, which can be simplified into m squared plus 1 minus 2m minus 4 times m squared plus 1 is equal to 0, or m squared minus 2m minus 3 is equal to 0. This can be further simplified into m minus 3 times m plus 1 times m squared plus 1 is equal to 0. Clearly, m squared plus 1 is a positive number, so the only solution for these equations will be m is equal to 3 or m is equal to negative 1. Recall that we have done for the case for m is equal to negative 1 in case 2, which gives us only 2 solutions. So we'll be only talking about the case m is equal to 3 over here. If m is equal to 3, equation 1 gives us x squared minus 6x minus 4t is equal to 0, which can be factorized as follow and give us x is equal to 10 or x is equal to negative 4. And equation 2 gives us x squared minus 4x minus 6t is equal to 0, which can be factorized as follow and give us the roots x is equal to 10 or x is equal to negative 6. In this case, we indeed get 3 solutions, x is equal to 10 or negative 4 or negative 6. This is the only value of m that we want. And this marks the end of our solutions. Post in the comment below if you have any thought on the video. And if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.